Hello, everyone. Welcome back to Tech Girls United's YouTube channel. I'm Megan Jacob, the founder and executive director of Tech Girls United. And today I'll be interviewing Kajal, an experienced robotics engineer. We'll be learning a bit more about robotics in the industry and how job seekers, high school students, and college students can get involved in robotics. Hello, Kajal. Welcome. I'm so excited to have you on the Tech Girls United channel. We can just get right into it. First off, I just wanted to have a little introduction about yourself. Could you tell our viewers about, your personal interests, your experience, why you're interested in robotics engineering, just something so that they can get to know you a little better?
Yeah, sure. Firstly, thank you for having me on this show. And hey, everyone. My name is Kajal. I'm a robotics software engineer and a YouTuber. What got me started into robotics was a technical internship I did during my undergrad. And my mentor was so nice. He showed me a few videos about drones doing flips and doing all of that autonomously. And that piqued my interest. And combine that with the love of coding and logical thinking, it's super fun. So that is what got me started in the field of robotics.
Awesome. That sounds really amazing. So, first off, I just wanted to know if you could, let us know what is robotics engineering as a whole. I feel like there are a lot of misconceptions about, what it means to be a robotics engineer, and it would be amazing if you could clear that up for our viewers.
Yeah, sure. So robotics engineering is basically creating robots that will solve real world problems. So for now, you might have heard in the news where there are delivery robots coming in that will it's either a drone or a small mobile robot that will literally drop an Amazon package at your doorstep. And that is what robotics is. It's a way for you to create a robot that will help solve some problem. It can be for doing things that nobody wants to do. So now imagine cleaning floors at malls and big stores like Target and Walmart. Nobody really wants to do it. People are starting and going into more creative work. So you do need someone to do those things. So that's a problem. And with robot, you can solve it. It's the same goes for your home. A lot of people are using Roomba because no one wants to clean their house. Vacuuming is not super fun task. Other than that, robotics is also sort of a combination of three engineering field. It's mechanical, electronics, and computer science. Because you're actually building a robot. You're deciding what motors to use, how much battery to need, so that you can run for long. But then if you have too heavy a battery, then it's gonna add to the weight and it's gonna slow down your robot. And at the same time, you need to think of writing a code so that the task can be done autonomously. Like your Roomba needs to be able to clean your house. So somebody needs to write a code that, the Roomba needs to go around and clean the house.
Awesome. Yeah, I think it's amazing to see, the different aspects that go into, a robot that you're creating for, each, task that you will be having. Okay, so then moving on, what does the day-to-day role of a robotics engineer look like? I feel like that would be something really interesting to learn about.
Yeah, and that's a very fun question. So a lot of times people think robotics software engineers especially would just be coding all the time. Versus in reality, yes, you are coding for a good number of amount of time in your day, but you're also doing all these other things. One of the biggest one being troubleshooting and finding bugs before you can even get to solve the bugs. So when you enter a company, there's already a code that you have to start with. It's not just you who's writing the code. There's a whole team of software engineers or developers who've created that robot and code. So now sometimes when you create your own little piece of algorithm, it's not going to work as you think it would. So now you have to dig down and figure out why it's not working, where something is going wrong. And that whole process is called troubleshooting or finding the bug. And that takes a considerable amount of time. And it is one thing that most people get surprised by that. Oh, I thought I was going to be writing code. Yes, you will once you find the bug. Other than that, it's also about attending meetings, and my favorite part, brainstorming. So like I said, robotics is about solving problems. So even with your Roomba, let's say you might have seen these funny YouTube videos where a cat sits on a Roomba and then it's just driving around, not knowing that there's a cat on itself. So now that's a problem. Now you have to figure out a way how to solve that. And it's not always on you to come up with a solution. You can always ask others for help, and trust me, it's so much fun to brainstorm with others. You can discuss ideas, you can get ideas from others, And then it's like, let's say you have 5 or 6 ideas. You're not going to go straight into implementing them because it takes a lot of time. So you want to sort of think through the pros and cons of these different approaches and then select the best approach that you can think of and go with it. There are times where it might not work out and you're back to it and, trying another idea. But the whole process of, sitting with a bunch of engineers or developers, sometimes people who are way smarter than you, and discussing ideas is super fun. So that is what a day to day looks like. You're coding, you're troubleshooting, you're attending meetings, and you're brainstorming.
Awesome. Yeah, I know teamwork, especially like I feel like that's something that's overlooked a lot of the time when you're looking into, careers or, roles in the like tech industry. But teamwork is such an important part of, any job that you're looking for. So I think it's really amazing that you brought that up. Okay, so then I think you kind of highlighted this already, but what has been your favorite part of working as a robotics engineer?
Yes, one aspect is definitely brainstorming that I just spoke about. It's also about the fact that you get access to people who are so much smarter than you and can give you a different perspective on things. So, for example, let's say you're trying to solve a problem of navigation. So, let's continue with that example of the Roomba. You're driving the Roomba around and you have to figure out a way such that it makes sure that it goes and cleans the entire room. It doesn't miss a certain part of the room. So now, if I'm a software engineer who has specialization in perception, I'm only going to think of it in terms of perception as to how I can use cameras to figure out and create a map. But let's say I start talking with someone who has expertise in path planning. So they're going to give me a completely different perspective and they're going to bring in some different ideas for me to try. And that part is fun. Being able to talk with others and creating this combination is great. So robotics, that is what robotics is interesting, right? It's not just computer science, electronics, or mechanics. It's sort of a combination of all of them. So again, the same thing, right? You also have to think about what kind of sensors you're going to use so that you can actually get that coverage. So you can compute where all your robot has gone, so you can know that I have covered all the aspects. So you might be, talking with someone who has much better idea about sensors. They may suggest that, okay, go for this or go for that. Like for another example, a lot of companies with robots use lidars for creating a map of the environment. But then you go and look at a company like Tesla. They are not using lidars at all. They're like, no, we're not going to use lidars, we're going to just use cameras. And that in itself is very revolutionary because the standard or the industry standard is lidars. Then here's someone saying that, okay, and I mean, I'm not saying that everyone just uses lidar. People usually use a combination of lidars and cameras, versus Tesla is like, no, let's just use cameras and figure out how to do it. So all of that is what's favorite for me in robotics, that you're thinking in different ways, you're being more creative rather than just implementing algorithms.
Yeah, definitely. I think like that's a really important part that like I guess people overlook as well, getting insight into like different perspectives, right? I think perspectives are key and it helps you also with like personal growth as well, right? Like you get to grow as a person when you see all these like different aspects. So I think that's really cool. Okay, so then what has been a challenge that you faced working as a robotics engineer?
Oh, that's a fun question. I think I have to say troubleshooting. So sometimes, you come up with an idea and you try to implement it and you think it's going to work in a certain way, but it doesn't end up working in that particular way. And sometimes it's the part of sometimes it's your code's fault where, you didn't write it correctly or you didn't follow the logical flow. But sometimes it's from another portion of the code. For example, let's say you created a path for your planner to follow, and you're relying on the controls aspect to ensure that it actually follows the trajectory. But in there, they might have certain assumptions, or they might have done some sort of optimization for certain scenarios which are not being used. So now that you started exploring this other option, it changes how controls is being thought of. So this figuring out, okay, what went wrong, or oh, actually controls doesn't think of this scenario, so we need to now also think of the solution. But it's very difficult to find out where things went wrong. So to give you a simpler example, let's say you created a calculator, okay, a simple code to compute the sum and subtraction and multiplication and division. Now you run the code and you write 4 and 5, and then instead of printing 9 as the sum, for some reason it's printing 6. But when you do 5 minus 4, it prints 1 correctly. Now, when you go into the code and you look at the line where it's, printing, it says print result, and it's fine, right? Like you're like, huh, okay, I'm, putting my everything in my result and it's printing result. It should print correctly. Why is it not doing that? But then when you go into the code again and start exploring it more, you realize, okay, when you were subtracting, multiplying, dividing, you saved your answer in result. But when you were adding those numbers, you accidentally saved it in a variable called sum instead of saving it in results. So now that is like not at the place where you're printing, but it's somewhere a little higher. So sort of going through that code and figuring out where things went wrong is more difficult than it might seem. So that is a challenging but fun part of robotics.
Yeah, it definitely sounds like a long process as well, trying to debug stuff. So, how long would you say that you spend on a project, like a single robotics project? And then how much of the time would you say like for troubleshooting?
Uh, Depends. I would say maybe, 60% of the time trying to figure out your project, implementing your solution, and then 40% amount of time trying to get it to implement and go through all the scenarios. There's a reason people say testing is super important. That's where you realize, okay, are things working the way I thought, and then going through the troubleshoot and so on and so forth. So, for example, in one of my projects, we were actually able to get through this portion very quickly, and we were able to finish the project in, I think, 4 months or so. But then there was this another project where we thought we will be able to get things done in 4 months. It ended up being, I think, 6 or 7 months, because a lot of things, a lot of problems started coming up when we started implementing it.
Wow, okay. I can definitely see that there's like a lot of like fluctuation and there's a lot of like uncertainty as well, right? You can't always predict how like the robot's going to end up working. So I think that's really interesting to see. It's not always as straightforward as it might seem to, people who are maybe using the product, right? They probably don't see like everything that goes in behind the scenes to make it work. So, kind of moving on then to people who are looking to get involved in this career option, what advice would you give to job seekers who are looking for a role in robotics engineering?
My advice would be to do projects. So I've seen a lot of people who would do courses or certification programs through Coursera or Udemy or any of these online platforms. While it's great to get theoretical knowledge, I would say go ahead and implement it as a project as well. Or go for courses that have a project inbuilt into the course. Because what ends up happening is, let's say, you learn the theory, but unless you implement, you don't know all the intricacies that go into it. And that is a huge learning experience. Not just that, even when you're looking for jobs, let's say, you create this resume and the person who's reviewing it sees that, okay, you've done a bunch of certification, but there's no way for that person to know that if you actually know those concepts. But if you show a project that you've worked on, or even a competition that you've participated in, then that's a great way for the person to know that, yes, you actually know what it takes to implement these algorithms. So, for example, path planning, right? There's a popular, so for example, path planning, there's a popular algorithm called A star. Studying A star versus actually implementing it, and it doesn't even have to be a big project, right? Just do it in MATLAB, create GUI for you to see the end results. A very simple maze or a very classic problem is called the piano movers problem. It doesn't take a lot of time, but the amount of learning you will get by actually implementing A star is humongous. So that's my advice. Do projects, even if they are small, doesn't necessarily have to be a big one. You will learn a lot and it is great on your resume.
Definitely. I know something I can like add on to that is also having like a profile, a coding profile where you store all of the stuff. So like I've used GitHub personally before and I know it's really popular amongst developers. So maybe having like a GitHub profile where you like store all of your projects and stuff like that so you can show it to employers when you're looking for a job would be really helpful.
Yeah,
So
that's a great insight. For me personally, I had GitHub profile and I had a website, and I walked into one of my interviewers, and my interviewer had seen my website, and they already knew things about me, and it's a great way of making an impression. So, we skipped the whole tell me about yourself awkward question. And this person was directly asking me questions about my projects they saw on my website. So, yes, great tip. Store your projects on GitHub or create an online portfolio.
Yeah, definitely. So now moving on to, high school and college students who are looking to get involved, what would you say they can do at this stage?
Great question. So, as I mentioned, you can do projects, and one of the great ways to do this is through competitions. There are lots of robotics competition for high schoolers and college students. So, first, robotics, of course, they're super popular. It's a great entry point. Another one is called RoboSub. A colleague of mine had participated when they were doing in college. It's basically creating an autonomous vehicle that goes underwater, and it's super fun to work on. Another one I think is called University Rover Challenge. This one is about creating sort of a Mars rover that can go on a surface similar enough to Mars. So again, these they might seem intimidating, but they're not that difficult. And you don't have to work on it alone. You're working it through a team. Most of these competitions means you create a huge team within your school or college, and then work towards this project together. And this is also great experience on how to work with teams, as we mentioned before. How to delegate tasks, how to communicate with one another, how to make sure everyone stays on task, because you're sometimes relying on another person to finish a task before you can do yours. So you want to make sure you can, talk to them and let them know that, hey, can you finish this? So I can also start working on my part. And it's super fun and great learning experience. So yes, my advice would be, participate in robotics competitions.
Yeah, I know also at the high school level, I have participated in like Bex Robotics, which is also similar to, First Robotics. And I think those are like really useful, especially with collaboration, which is something you mentioned a few times. I've noticed that's really key to, get that collaboration in on like a robotics team. And if there isn't a robotics team in your community that you can join, you can always start one as well. I know like Vex and First both have like simpler procedures they can follow online to get started and start building a team in your community if you want to be the first one to try and get more people into robotics there. So okay, so we're coming to an end pretty soon. So what final advice or words of motivation do you have for any aspiring robotics engineers?
I would say you have to sort of go with the right mindset. So for me, when I think of robotics, it's fun. It's about solving problems, trying different solutions, thinking logically, and that inspires and motivates me. So because there are going to be times where you're given a problem and you will end up being stuck on it. Like I said, a lot of time you have to spend troubleshooting. And when you're doing this, you're kind of stuck and you don't know what's wrong and you don't know how to move forward. So in times like that, it's very important to sort of, go back to like, I know it's tough, but I just have to think a little outside the box. I have to go ask for help from others and see if I can get some sort of an input and some sort of a direction that, hey, I'm only looking at this. Then you go talk to someone and they're like, hey, did you check this particular code? I know that they might also have some problems. So sort of doing all of that and having that mindset that, yes, I'm going to get through this is super important to succeed in robotics, because you're going to get into trouble. And even though there are like all of these algorithms that are coming from the academia side, when you try to implement them, you will run into problems. So having that ability to ask others for help, and having that mindset that, yes, like I'm going to get through this. Yes, it's a little tough, but it's also fun. So having that motivation and mindset is really helpful to succeed in robotics.
I definitely agree, especially like the willingness to learn. I feel like that's really important. I feel like in any role as well, right? You have to be willing to learn. It's not just, having the skills necessary, right? I feel like a lot of people think that, just like learn the skills and then walk into the job, right? I think what you really like, highlighted here is that there's so much more to it. You're going to be learning throughout the process. It's not, you walk in with what you need to know. There's so much you're going to learn as you continue working. So I think that's really useful for anyone who's watching this. And I feel like this talk was really, beneficial. I learned a lot from it. So thank you so much for being here. And I love talking to you.
Yeah, thank you for having me. And what you mentioned in the end is completely true. It's not about all the technical skills that it's way more about your attitude. Technical skills can be learned, attitude and mindset is much more difficult. And once again, thank you for having me. And for all the viewers, I hope this talk was helpful to you in terms of how to get started with robotics and any other questions you may have. And you can always reach to me through my YouTube channel or my LinkedIn.
I'll link your channel in our description, and you can any viewers can take a look at that and find more resources in robotics over there.
And make sure to subscribe to her channel as well because there's more amazing interviews coming through.